Kubernetes and CKAD tips number 22. Here we will be talking about persistent volume in pods, and this is very important and a bit complex. Why it is a bit complex? Not the implementation perspective, but from the conceptually. So we need to first clarify how this thing really works, and then work towards the problem, and then try to see how we can implement a similar solution in our scenario. So what I'm going to do is that I'm going to try to draw some diagram out of it. Now imagine that you are running a pod, and then that pod is in a node. So this is the node, the big box, and then you have got pod running inside the node. So these are all pods. So these are all pods, and this is the node. Okay, that's the actual machine. And then inside each of the pods, you have one or more containers that is running. Now, what happens when you use volume or volume mount? In that case, you basically say that, hey, I want to create a volume somewhere, and then I want to mount that volume inside that uh, container, and then it works seamlessly. Now, in the persistent volume, it is similar to that concept, but works in a different way. So think of it like, imagine that you are creating a volume in the node, right? You can also create the volume in other location like cloud. So for example, let's say you have got a folder created over here, and then you say that I want to map this folder over here, but you want to map it in a bit different way. So persistent volume really comes with two things. One is volume, right? And then another is claims. Now, how these two things tie to each other and work together is not because one-on-one mapping, but these are all like other Kubernetes objects. For example, services and deployments and pods, which are loosely coupled, right? They are also loosely coupled. The claim is sort of like a floating thing which keeps checking the matching criteria given within the claim to find the available volume. So if it finds an available volume which matches the claim criteria, it will bind the volume with the claim. And we use this claim to produce a pod. So when you create a pod, we use the claim, not the volume. So you understand here, we don't create a volume inside our container or a pod pointing to this. We don't do that. This is not what something we do. Rather, what we do is that we take this pod, and then we take connector over here, right? So that's a kind of option we take over here, and then make sure that we kind of have that capability uh, to associate the claim in whatever the available volume we have. So let's see that how this relationship really looks like in the declarative way. So we need, first of all, a couple of YAMLs. So let me bring few YAML from the already existing one, which we should not be creating by hand. So you should refer to the Kubernetes documentation and use this. So now if you start analyzing this um, YAML file, you'll observe that this YAML file contains few things. Number one, it has got the kind, that is your persistent volume, right? That's a kind we are creating. So we first need to create a persistent volume. And then we give three things. One is, what is the storage class? So there could be different storage classes available. So we choose manual. And then what is the total capacity of this storage, right? So if we say that this is the total capacity, that is 5 gigabyte. And then what is the access mode? That is read write once, right? So there are a couple of different access modes available, couple of different storage classes available depending on how you want to create that volume. So it really matters. So these three things are the key important things. Now comes the next thing, right? What are they? They are basically, that's basically your persistent volume claim. So if I have them side by side over here, let's put it side by side. And I just want to show you the relationship over here. You see that I have now, maybe I can just reduce the size. I have now this uh, I have now this persistent volume claim. That's an object which I'm trying to create, right? And I want to show you that in a nice little diagram, right? So I just wanted to draw this. Maybe I can point you to that, the line number in the persistent volume claim. So let me just reduce this, go over here, and then try to maybe draw something. Um, Okay, so you can see that in the line number 7, you have the name, line number 9, you have the volume claim, and then you have the manual thing. So if you notice them both side by side, let me just copy it again, and you just notice them side by side over here, right? And then if you see that we have got something matching. We have got a storage class name manual for both volume and claim. We have got a storage capacity here in the volume as 5 gigabyte, whereas in the claim we asked for 3 gigabyte. Imagine that you have only one claim, then this volume basically has got enough availability in this case. So you can basically go ahead and have this volume bind to that persistent volume claim over here. That's what I mean to say about the availability. Now, imagine some other claim asked for, let's say, 3 gigabyte already. Now, this 5 gigabyte has got only uh, basically have got 2 gigabyte available. So this claim will not be able to bind to this volume. So it will start or wait for another claim to be another volume to be available to attach that. So it needs to match both the things. So it needs to match with the storage class name. It needs to match with the access mode and the size or the available size here. Now, then after everything, right, what you need is that you need the actual pod, which will use the name of the claim, just the name of the claim, and nothing else, right? So you don't need to really specify what is the persistent volume you might want to use over here, right? So for example, if you say that I want to use um, this claim called PVC claim. So you just mention that claim name and it will fetch the claim for you, right? And if that claim has a bind volume, then it will get the claim and it will be able to bind it. So you get it inside that volume here. You can see over here, it's getting inside the volume. And then you can basically do that over here inside the volume mounts. So let's try to run them in my local machine and then see the status. Now, at this point, I do not have any persistent volume and persistent volume claim. Just to make sure that I do not have any, I say get PV and PVC. So these are all short form of persistent volume and persistent volume claim, and I do not have any. That's all right. Now, what I'm going to do, I'm going to show you that the PV, that's the same YAML file which I demonstrated. So you have got this manual class, 5 gigabyte read write once, okay? And it basically points to a host path called MNT data. That means it is in the node, right? In my node. You can also specify some other directory or folder if you have, and then add files over there, and it will stay as long as the node is with you, right? So if you want to store something outside of the node, you should always prefer that over anything local to the node, because sometimes node gets recreated, then you lose all the data. But however, this is the way how it works in the node perspective. So if I come out of that and then say k create minus f pv YAML, and then it will create a persistent volume. To see the persistent volume, you say get PV, you will see only one persistent volume, which basically says, let me increase the size of the screen, which basically says that I have got one volume, which 5 gigabyte read write access, read write on once, and then the claim policy is written, it's available, and then it is manual storage class. So these are the key criteria you need to be careful about, right? What happens when you basically create the PVC? So let's say the PVC file. So if I have pvc.yaml, you see it's a fairly simple. I do not have any one-on-one mapping that I need to map it with the persistent volume X, right? There is nothing like that. I haven't mentioned anything. I do not need to mention anything. And what I need to mention is three things again. What is the storage class name? What is the access mode? And what is the size I require? So if all the three criteria matches with the available set of persistent volumes in my what I have in my system, it will match. And the persistent volume is outside of the namespace boundary, which means that it stays. And then you create a persistent volume within a namespace, but it can match with any of the persistent volume outside of the namespace. Okay. So I will just come out of that and then create that object. I say k create f pvc.yaml, it gets created. Now you notice here the previous PV status. And now if I say k get PVC, it will get you the PVC and it will show you some status called bound, right? This is important. And now if I instead of getting PVC, if I get PV, you see that it now has got something called claim. Now it shows that this PV or persistent volume now bound to this claim, right? So which means the system is ready for me to now create a pod which can basically use this claim as a storage location. So let's see the pod YAML. So let me see what is the name of the file. I think it is pvc pod. So if I say vim pvc pod.yaml, it'll show you that pod, and it's fairly simple. You can see inside volumes, I give a name. That's what I will be using. And then I use persistent volume claim name here. So the claim which I created, that name I use. Only that's the connector, right? So that's how I select the claim. And then you come to the volume mount, rest all remain same. And then you see that I have got a mount path. So you can mount to any path, right? So you can have your own folder structure and can mount that folder into your own folder structure and give the name of the volumes, which we already discussed in earlier um, chapters, that how can we mount a volume within a container for a pod, right? So we are mounting using the name, that is task PV storage, right? That's the pod definition, how it looks like. Now I just say I want to come out of that. So I'll say that I want to come out, and then I say k create minus f pvc pod dot yaml, and it's gonna go ahead and create the pod. Now, if you see that if the pod is created or not and everything is fine, it says running, which means everything works fine. There is no error. Let's go inside that. If I say describe pod pv pod, that's the name of the pod. And then if you see little up right inside the container under mounts, right, you can see that we have got user share nginx HTML, and that basically got mounted from task PV storage, which has got a read write access, right? So that's what this happens here. You can even see the folder is actually available in your local machine, right? So in the inside the container. So if you go inside that, to do that, you say kexec popv pod, and then I say interactive terminal, and then I open the shell command. If I do that, And then if I run this and I say ls, I get to see all the folders. You get to see that user folder is available. So you say cd slash usr slash share slash nginx slash html. User, not use, sorry. So I'll say cd usr, not usv, share nginx html. Everything is fine. It will go inside that. And then if I say ls, there is only h1 available, which is what I manually went ahead and created. And you can just see, say cat h1, and you will find that h1. So if you use the same persistent volume claim to populate another pod, right, you will find the same folder available. So let's see that experience over here. So let's use the another file called p. So let me check what is the name of the file. If I go ahead and then say pvc2.pod, which I just wanted to make sure that they are using the same name. So if I say pvc2.pod, you see that it is using pvc claim, the same claim, right? And you can have a different folder also, so you don't need to be in the same folder. You say that I want to put it inside user html, right? If I go ahead and do that way, you can map it to any folder. So k create -f pvc2.pod, which will create another pod. And if you say k exec pv-pod2 -itsh, and it goes inside that, and you will see that there will be a file created called user. So if you say usr, that folder is there, and then you say ls, you find the html inside, right? You can see that html is available. cd html, if you go do that and say ls, you find the new file ls. So I just have the folder available inside this same location, right? So you basically get to see everything what is kind of required for it. So you can see that this uses the same use PVC claim, and it mounts to both the pod, right? So that's how it works in the persistent volume world. If you get to see now k get pv, you will see that this is again pointing to that, and you have basically PVC, k get PVC, and then you just see that it is still working bound. That means it is doing fine at this point in time. If I, let's say, delete, because they are disconnected, right? If I delete, and then what happens if I, let's say, try to delete this PVC and then say I want to delete this PVC claim, and it deletes because there is no tight integration between, and that could be a problem at my inside my pod, which might not work as expected, because then it won't be able to communicate. Or if I, let's say, delete the volume, that could be an issue. So you might want to restrict who can delete or how that thing deletes. So that is something you need to be careful about when you work on a production kind of scenario, and then not let people delete the things which is kind of dependent for other objects, because they're loosely coupled, easy to use, but you need to put some governance around those kind of accidental deletion. So with this, I want to thank and thanks for watching persistent volume and persistent volume claim, and how you can map it with your newly created pod as a volume mount.